Welcome to Chapter 5. We're going to talk in this section about vector fields and what exactly is a vector field. How do I visualize a vector field, and maybe what is some of the stuff that's good for? So as I state here at the top, so far in Calc 3, what we've looked at are a bunch of different kinds of functions. We've looked at vector functions, which were functions that took single numbers like a t and transformed them into vectors. So things in Rn space. We also took a look at functions that took in x's and y's and spat out a z, or took in multiple inputs and spat out a final input. But for the final chapter here, in what we call vector calculus, we're going to be able to start taking a look at functions of the form that take in an unspecified number of some specified number of inputs and spit out some number of outputs. So I might have a function that can take in an x comma y comma z, but can also spit out a u and a v and a w. Right? So I could maybe have functions that spit out a whole bunch of different values while also taking in a whole bunch of different values. So to kind of get a sense of what something like this might actually look like, we can see here the following definition. So we're going to say let D be some set in 2 space. So good old 2 space XY axis. We'll say that a vector field on R2 is a function f, one of these new capital F functions, and it assigns to each point x comma y in D a 2-dimensional vector. So notice it's taking in an x comma y, but it's spitting out a vector that's going to have 2 components. We could also imagine that we could say, let E be a set in 3 space, and a vector field on 3 space is a function that assigns to each point in 3 space a 3-dimensional vector. So here's a function that takes in 3 inputs and spits out a vector that has 3 components. So when we think about this idea of a vector field, this is going to be an important concept throughout Chapter 5. And so we're going to start by just trying to understand what exactly is a vector field, how would I maybe visualize it? So I'm going to use a picture to illustrate what this vector field actually looks like. And what you can see here is I have one of these capital F functions. You'll see that it takes in 2 inputs, and what it spits out is a vector. And I want to understand how this really works. All right, so what I can start to do is the same thing that I've always done since algebra when I don't really understand what a function looks like. I can try to almost graph it. The weird part here, though, is I have to think about plugging in x comma y's and getting out a vector that spat out by this function. Now, of course, here it's not too difficult to see how the formula works. Like, let's say for the sake of argument, I plug in 0, 0 as my x comma y. What would be the vector that I would get back? Well, it's not too surprising. If I plug x in for all the x's and y in for all the y's, I get the vector 0, 0. I get the 0 vector. Okay, but I could see a lot of other points on here. Maybe I plug in 1, 0, and that means I'm going to get something that looks like, well, let's see, that would be 0, 1 is the vector that I would get back. I could plug in 0, 1, and I would get back something like -1, 0. So again, I'm plugging in points, I'm getting back vectors. Now I'm going to try a whole bunch of different points here just to kind of get a lot of points I can put into a picture here. So let's see, if I plugged in -1, 0, you could see here that I'm going to get 0, -1. If I was to plug in 0, -1, I should get 1, 0. And if I plugged in 1, 1, you can see I get -1, +1. And if I plugged in -1, -1, I get back 1, -1. So every point again that I'm plugging in is creating a vector. What I want to maybe start to see is what exactly this is going to look like when I begin to graph this out and place these vectors into space. So over here on the side, I'm going to create a nice little XY coordinate system. And I can see here that I'm using a lot of 1s and -1s. So let me just quickly kind of mark out on my axes where those 1s and -1s would occur. And here's what I can see that I can do. I could do something kind of like the following. At 0, 0, I should be able to draw the associated blue vector 0, 0, which would just look like this. There's not much happening there. If I was to go ahead and draw out some of these other pieces, I can get a sense of what this might look like. And I won't draw all of these, I'll just draw some. So imagine I went to the point 1, 0 over here. And then I drew the vector 0, 1. Well, that would say move 0 units in the x direction, but 1 unit in the y direction. And I could create a vector that looks like this. So there's a vector that's being created by that point. Notice if I did the same thing with the next point. Maybe I go to 0, 1, and I draw the following vector in blue. I go backwards 1 in the x direction, and I don't go up or down at all in the y direction. Right? So I have lots of these, and I'll even skip around to take a look at a bunch of these different values. Notice here, if I was to do something like 1, 1, that would be starting up here at this point. I could see that I get the vector -1 in the x direction, but +1 in the y direction. That's going to be a vector that maybe points out and does something like this. So I'm going to start to get a whole bunch of different vectors in here that point in a whole bunch of different directions. Take a look here. I could go to 0, -1, and then the vector that I create should go 0 in the x direction, but down 1 in the y direction. Oh wait, that's the wrong point. -1, 0 would be over here, and then I would go ahead and point down. My apologies, right? So like I can get a whole bunch of different vectors that are all kind of swirling around. And so I can start to get a picture of what this vector field starts to look like. Now I'm going to go ahead and go to the 3D grapher really quickly and show you how you can actually sketch one of these vector fields in there. So if I go over here to the 3D grapher, you can see that I have a whole bunch of different options in here. And one of them actually is vector field. If I click this, you'll notice that it is ready to have 3 different components to be used here. And you'll see that when I click this with a check mark, it has a formula kind of already in there. And you can see all these different vectors floating out in space. And maybe these vectors represent a whole bunch of different things. Maybe they represent like air currents or like flow of water or like the motion of something. And so we can model a lot with these sorts of vector fields. Our specific vector field had an x component that was going to be -y, and it had a y component that was x, and we didn't have anything for a z, so leaving that as 0 sounds fine. So this was our vector field. And notice I'm going to click this button down here that says restrict this view to 2D. So this was the picture that we were creating. Right? We didn't have all those vectors in there, but we maybe had some of them. We sketched a couple. And so, yeah, maybe this is like some sort of swirling whirlpool motion. And these vectors help me understand the motion at any individual given point. So this is at least the purpose of a vector field and what it's actually designed to help do and create. And what we'll see in the remaining videos in this section are some of the other quick descriptions that we can kind of vector fields and ultimately kind of lay some of the groundwork for what we're going to be doing with them throughout the rest of this chapter.